In this video, I wanted to talk a little bit about fractional and negative exponents because in the last video, I used a calculator, or I just told you how to say take 4 to the 0, 4 to the minus 1, 4 to the 1/2. But it's often hard to think about why do they mean the things they do. And the way I like to explain it is by looking at it in terms of patterns. So let me get my head out of the way. And because I think that this sort of table will help us understand what does an exponent mean, and how can we extend it to negative or fractional numbers. Because in general, we know the basic definition of what an exponent means. It means I'm going to multiply that many of the numbers together, right? 4 squared means 4 times 4. 4 cubed means 4 times 4 times 4. 4 to the 4th means 4 times 4 times 4 times 4, and so on. But how do we extend that for those other weird values? And notice that in each of these, I have a 1 here. And really this is kind of an explanation on the fundamental 4 to the 0 power. Why is that 1 and not 0? Because 4 to the 0, extending this idea, well, if I have 1 4, that means I have one of them. 2 means 2, 3 means 3, and they're all in a multiplicative succession. But if I have no 4s, usually nothing is nothing, right? Nothing is 0 in math. However, since an exponent is always in the realm of multiplication, 0 is not like nothing in multiplication. If you have no factors or no multiplication, 1 is what's often referred to as the multiplicative identity. It's kind of like the starting point, the 0 value, when you're multiplying things. Because if you think about taking each of these chains and starting at 0, 0 times 4 is not 4, it's 0. And same with each of these other ones. So starting with 1 makes sense when I'm multiplying, if I'm thinking about, well, what's the origin, what's the starting value of this multiplicative pattern? And that's exactly why. And if you return back to the graph we built for 4 to the x in the last video, notice that that y-intercept fit really nicely in that curve, and that's another way that kind of makes sense. But basically, 1 is the starting point for multiplication. Since exponents always mean multiplication, the intercept for that has to be 1. And also, the next thing is, well, what about negatives, and what does that mean? Like how do I extend the exponents to the negative? But basically, thinking about an exponent means repeatedly multiply, and negatives always in math refer to an opposite, right? 4 minus 4, 4 divided by 4, and that's the multiplicative opposite. And that's kind of why, as I said in the last video, when I'm taking the minus 1 power, that always is equal to 1/4. Or there's the rule that if you have 4 to the minus n power, that's equal to 1/4 to the n power, the whole reciprocal rule. But what I wanted to mention is, notice it actually fits this pattern, because a positive exponent means I'm multiplying by 1/4. A negative exponent means I'm dividing by 1/4. And remember, division is the inverse to multiplication. It's the opposite, and that's the key reasoning for negative exponents being referred to division. And this is kind of how I'd like to teach this idea, is that we think of positive exponents as repeatedly multiplying. Well, negatives are much the same. It just means I'm going to be repeatedly dividing instead. And that's a way to remember this rule, the reciprocal rule for negative exponents. And 4 to the negative 2 would just mean, well, I'm taking 1 and dividing by 2 4s. And again, 1 is the starting point, right? So it kind of makes sense why we have the 1 within that expression, and it's 1 divided by 4 to the squared. And so forth, right? 4 to the minus 3 would be 1 divided by 3 4s. And 4 to the 4th would be 1 divided by 4 4s. And like even extending this a little bit further, what about fractional exponents? How does like the 1/2 power fit into this pattern, or 3/2? But it's sort of like, again, when we're in the realm of exponents, we're always thinking about multiplication and repeatedly multiplying by that many things. How do I have a 1/2 of a 4? What does that mean? Well, obviously it's like not a direct multiplication of 1/2 of a 4, but in terms of factoring 4s, like if I think about the number 4 factors is 2 times 2. So if I was thinking it in terms of factorization, which all of this whole chart is built on factoring those numbers into that many 4s. Basically, 2 is 1/2 of a factor of 4, and that's exactly what the square root of a number does, right? It looks for what squared makes the number, and it's kind of like I'm extracting 1/2 of a power, 1/2 of that factor. In this case, it coincidentally gives me exactly 1/2 of 4, which is 2. But like when you're looking at 4 to the 3/2 power, that's not going to be 6. It's a common mistake for students who don't have a calculator handy. But again, it would be like if I had 3/2 of a factor. Well, 2 is a half factor of 4, and if I have 3 of those, that would make 8. And that's exactly why. Basically, I could think about that as 1 times 2 times 2 times 2. Because a half factor of 4 is 2, and if I have 3/2, that would be a chain of 2. And so I don't know, like I'm trying to wrap this video up right now. But basically, there's a lot of patterns within exponential expressions, and there is some sense behind fractional values. Though at the end of the day, if you're not really sure, you can always relate back to rules like such that, you know, if I have a to the minus n power, that's equal to 1 over a to the n. Or if I have a to the m over n power, these are those critical rules of algebra for this section. I could always write that as a radical expression. But those rules have some sense. That's kind of the point of what I'm driving at here. And it's all based on patterns within multiplication. Because at the end of the day, that's what exponentials are, repeated multiplication. And if I have weird numbers in there, we can still figure them out. It just does takes a little bit deeper thinking.